All right, let's pick up with where we were. We were looking at, we just finished question 9, so question 10. We are looking at describing the effects of f of x equals 2x and g of x equals f of x plus 5. So what we would see with g of x equals f x plus 5 is that because f of x equals 2x, we're going to take that 2, drop it there, and we'd have x plus 5 here. And so if we distribute that, we end up with 2x plus 10. So we're comparing 2x to 2x plus 10. So how do the slopes compare? They're the same. That's one piece. But we've learned that this piece is a left and right movement, and it's the opposite of what we think it is. So since it's positive, it's actually a left shift there. In our y-intercepts, we can see here, right? We can see that the y-intercept went from 0 to 10. So that positive 5 told us that it increased, but it actually increased by 10. But increased because this was a positive value there. Find the value of f of 3 for the function f of x equals negative 4x plus 2. We will simply replace x with 3 and evaluate that. So 3 plus 2 is 5. We get negative 4 times 5, which is negative 20. So f of 3 equals negative 20. I use the diagram to find the domain and range of f. Our domain would be 18, 24, and 17, or in order 17, 18, 24. Again, those are your x values or your inputs. Your range here would be then the outputs. So this is our range. This would be our domain, 13 and 10. Solve the system using your method. With one of our equations already being in y equals form, substitution makes the most sense here, because we can go ahead and take this 4x minus 6 and sub it in for the y value. So we can rewrite that x minus y equals 0 equation to x minus, and then it's 4x minus 6 equals 0. Now notice that I put that in parentheses because it was x minus y, so we're subtracting that entire thing. So we do need to distribute that negative sign through our parentheses, and we end up with x minus 4x, but then plus 6, because we've got that double negative scenario. So we get x minus 4x, which would be negative 3x plus 6 equals 0. We need to get x by itself, so we'll subtract 6. We get negative 3x equals negative 6, and divide by negative 3, and divide by negative 3, and x equals 2. Now, this is solving a system, so we're finding a point. So all we have done is found half of it so far. We now know that the x value is 2, but we need to figure out what the y value is. So we're going to take that x equals 2 and drop it into either one of our equations, either into here or there. It doesn't matter. But I'm going to drop it into the second one. So I'm going to go y equals 4 times 2 minus 6, which will be y equals 8 minus 6, which is y equals 2. So we are thinking that the x value is 2 and the y value is 2, or 2 comma 2. We can check that by taking the x, here, x minus y equals 0. X we said was 2, y we said was 2, equals 0, and obviously 2 minus 2 is 0, so that checks out. Or, in the other one, we said y was 2 equals 4 times 2 minus 6. 2 equals 4 times 2, which is 8 minus 6. 2 equals 2. And that checks out. So we know we're good with our 2 comma 2 there. All right, 14, match the inequality. The first thing that I would see here is the fact that this is just a less than sign, which means it's going to be a dashed line. So being that's a multiple choice question, the 2 solid lines are out. The second piece then would be, okay, I've got 3x plus 4. Are these lines graphed correctly for 3x plus 4? And they both appear to be y-intercept of 4 and apparently up 3 over 1. So that doesn't help us. So now we got to figure out, okay, which one of these works. And so we talked about the shading piece. And if I take a point like 0, 0, and I'm going to put it into this inequality, so I'm replacing x and y with 0. And if this is true, then 0, 0 should be shaded in, and we'll go with B. If this is false, then 0, 0 is not going to be shaded in, and we'll go with A. So 3 times 0 is 0. 0 plus 4 is 4. And 4 is greater than 0. So that is true. So 0, 0 should be shaded, which means B has to be my answer. All right, 15, we get into some exponential stuff here. So we have a city that's population's 200,000. That's what we're starting with. And it's growing at 2%. So we talked about 2% being the same thing as 0.02. And then because it's growing, we got to be greater than 1 or 1.02. So that's our B value. Our A value is going to be that 200,000. So our equation would be 200,000 times 1.02 to the power of x equals y. If we want to find the population in 10 years, we're going to use that equation, 200,000 times 1.02. But instead of to the, or sorry, this should have been an x over here. I screwed that up. So instead of that x there, this shall be a 10. And then we would just throw that into our calculator, and it's round to the nearest whole number, which is 243,799. Again, this piece here is that number of years we would want, because that's where our variable is. Without graphing, determine whether this function represents exponential growth or exponential decay, and then find the y-intercept. So we are looking solely at the b value, and if our b value is greater than 1, we are going growth. If our b value is less than 1 but greater than 0, like 0.2 or 0.8, we would have decay. Our b value is 2, so our b value is greater than 1, so we've got growth. And then our y-intercept, that is your a value. So our y-intercept would be 8. Simplify the product. We've got our foil or our box, however you want to do this. We did a lot of boxes with this one. So 2x there, positive 9 there, 3x and negative 5, and we'd multiply 2x times 3x, or 6x squared. This one will be 3x times 9, or 27x. This one will be 2x times negative 5, or negative 10x. And this one would be 9 times negative 5, or negative 45. So we've got 6x squared plus 27x minus 10x minus 45, and our middle two terms will combine to 6x squared plus 17x minus 45. Factor this trinomial completely. I need two numbers that multiply to negative 24 that at the same time add to 2. Again, this is the multiply. This is the add. Again, I can do that because the a value here is 1. So what multiplies to negative 24? Well, I know it's got to be a positive and a negative number. I've got a whole bunch of them. I've got 24 and 1. That's not going to work. I've got 12 and 2. That's not going to work. I've got 8 and 3. That's not going to work. I've got 6 and 4. That looks like I can get that to add to 2 if my 6 is positive and my 4 is negative. So that tells us that we're x plus 6 and x minus 4. And again, if you want to check that, you would throw that into a box and put x6, x negative 4 and see what happens, but we should end up with what we started with. 19 says factor out the greatest common factor, then factor what's left over. Again, anytime that this value is not 1, we want to factor out a GCF or look for a GCF. So it just so happens that 12 is divisible by 12, 12 is divisible by 12, and so is 72. So that is my GCF. 12x squared divided by 12 is x squared. 12x divided by 12 is x, and negative 72 divided by 12 is negative 6. So I got the 12 out in front, then I've got this trinomial now, x squared plus x minus 6. I'm going to factor that with the negative 6 here, and that value that's attached to the x, which is a 1 there. So I need two numbers that multiply to negative 6 that add to 1. Again, I know 1's positive, I know 1's negative, I know it has to be a 3 and a 2, and I know it's positive 3, negative 2. So that piece becomes x plus 3, x minus 2, but remember we factored out that 12 originally, so we can't lose that. That goes with our factored trinomial. X plus 3, x minus 2 times 12. Number 20, identify the vertex AOS in direction of the graph of the function and compare the graph to the width of our parent function x squared. This is written in vertex form. So remember, this right here is your x value, but it's the opposite, so that's negative 3. That's your y value, so that's 6. Your AOS is always your x value of your vertex. So we would just simply say x equals negative 3. The a value, which is right here, is 2, which is positive. So we are opening up. And 2, again, this value here is greater than 1, which actually makes it a skinnier or narrower function. Remember, the bigger that number gets, the skinnier we get. So that was in vertex form. 21 is in standard form. In standard form, the easiest thing it tells us right out of the gate is the y-intercept. That's the gimme. That's negative 5. Our AOS, we got to do a little bit of work for that. That's going to be our negative b over 2a function or expression, or the opposite of b over 2a. Our b value is negative 6. So I'm going to put this as negative 6 over 2 times my a value, which is 1. Double negative up top becomes positive, so positive 6 over 2, which becomes 3. So axis of symmetry is x equals 3. And our vertex then would be 3, comma, and I'm going to go use that equation, x squared minus 6x minus 5, replace the x with 3, and evaluate this. 3 squared is 9, 6 times 3 is 18. 9 minus 18 is negative 9, negative 9 minus 5 is negative 14. That's our y value. of our vertex. Writing this in standard form, first thing we got to do is evaluate that. So I've got x plus 3 squared, x3, x3, x squared, 3x, 3x, and 9. That is x squared plus 6x plus 9, and then minus 2. Then we'll distribute the 2 through that trinomial to give us 2x squared plus 12x plus 18, and then minus 2 on the back side. And then we can combine that to give us 2x squared plus 12x plus 16. All right, let's leave that there. We'll come back and finish this in the last video.